In this video, I'm going to begin by reviewing some of the methods on the path interface with you. I've created a new project called Path Listings for this video. I'll start with a private static void method called printPathInfo that takes a path instance. This method will use several methods on path. I'll start by printing the path. Path has a method called getFileName, so I'll invoke that and print what gets returned. I'll also print the result of another method, getParent. I'll get the absolute path via a call to absolute path and assign that to a variable and print it. I'll use the absolute path to get the root via a call to getRoot and print that. I'll also call the getRoot method on the current path to compare that to what I get above. Next, I'll print the Boolean value I get back from the isAbsolute method. I'll end with printing a separator line. In the main method, I'll call this method. First, I'll create a path variable and assign that a path instance using the factory method of onPath. In this case, I'll use a string literal, which contains a file name as well as a reference to its parent folder. I'll pass that to my method, printPathInfo. This folder and this file don't yet exist in my project if I run this now. There are a couple of things I want to point out. In the first case, when you print path, you can see it's what you constructed it with, so it's giving me back what I passed in the string literal. The getFileName gave me testing.txt, and the getParent returned just files. Here is the absolute path using the path instance. From that, I can get the absolute path's root directory. But notice next that just calling getRoot on the original path returns a null. This is one indication that this is a relative path. To confirm that, I can see that the result of calling isAbsolute is false. Let's now print the hierarchy of this absolute path. I'll insert this code before the last separator line. I'll print the root again. I'll initialize a counter, which I'll use for indentation. I can get an iterator of all the folders that make up the path instance. Here, I'll use toAbsolutePath since I want to start at the root chaining a call to .iterator. I can loop through this iterator with a while loop, checking the hasNext value on the iterator. I'll print the current element, so it.next, with some indentation to the output. I'll rerun this code. Okay, so now you can see the full hierarchy of the file path, including where the new file would be placed in this tree. Each iteration represents another subfolder, and I've displayed this in a rudimentary way. Instead of using an iterator to loop through the directory tree, I can use two other methods available to me on path, which I'll show you next. Getting back to the printPathInfo method, I'll first comment out the iterator code. I can get the depth of the directory tree by using getNameCount. I'll use the absolute path here again, because I want to start at the root for this exercise. I'll loop from 0 to the folder depth. I'll print the same statement I had before, but in this case, I'll get the directory name at each level by calling getName on the absolute path, passing it the current index value. I need to add 1 to the index I use in the repeat method, because the first folder, or index of 0, isn't the root. Running this code. This gives me the same output as I had when I used the iterator. Using the getName method, though, gives you a lot more flexibility in how you might iterate through the file tree. In this hierarchy, I know that the last two paths don't exist yet. I'll create some code to fix this, first by creating another private static void method. I'm going to call this log statement. This might seem like a strange name for a method that will create my file, but you'll see why I'm calling it this in just a moment. This takes a path as an argument. I'll start out with a try block because I know I'm going to need it. I want to first get the parent folder of the last element in the path, which the getParent method does. If this folder doesn't exist in the file system, I want to create it. I can do that with the static create directory method on files, passing it the parent path. That method throws an IO exception, so I'm catching that here. Since my plan is to log statements to a file, I don't want to throw an exception or quit if I can't. This kind of ignores the error unless someone's watching the default output. Next, I need to create the file. There's a method that lets me both create and write to a file in a single statement, so let me show you that. I'm going to again use files.writeString, which I used in the last video, passing it path as the first argument. The second argument is the string that will get printed. Since this is a log file, I'll include date and time. I'll use instant.now to get a timestamp, and I'll print hello file world with an ending new line character. This method takes a third argument, the last, and that's a variable list of option types. You can find these options on the standard OpenOption enum in the java.nio.file package. First, I'll specify the create option, so if this file doesn't exist, it will get created for me. Second, I'll say I want the append option, which means each statement will get appended to the end of the file. I'll cover these options and others in more detail in upcoming videos that cover reading and writing to files. Next, I'll go to the main method and add a call to this newly created method. Let's run the code and see if this works. I don't get any additional messages, but if I open the project panel, I can see the files folder has been created, and in it is the testing.txt file. If I open that file, there I can see my log statement. If I run the code again and look at the file, I'll see a second log statement was added. Okay, that's great, but what happens if my file path contains several folders that don't yet exist? I'll set that up and change my path to include some more subfolders. Here, this entire path of folders don't exist. If I run the code with this path, I get a no such file exception when I call the create directory method. I could put this code in a loop, one that iterates through the paths, similar to what I did printing out the paths earlier, but the files class gives us a better option, a method appropriately called create directories. I'll go to my log statement method and simply change the method I'm calling here. This create directories method will work on one or many folders, so I could have used it previously with testing.txt that was in the files folder as well. Okay, so if I run this now, I don't get any errors. From the project panel, I can see the directories were all created, and there's my new testing.txt file, so I'll open that, and I have a log statement in there. I don't want to go too deeply into writing to files in this video, but I did want to give you a real quick sample of this one-stop shop method to create and write to a file. I want to get back to the paths methods, so let's see what kind of information we can get about this file. I'll create another method called extraInfo, so private static void, and it also takes a path. I'll start out with a try statement to save time. I'll call files.readAttributes, which takes at least two parameters, the path and a string. The string defines a list of attribute names you want information about. You can pass an asterisk, which is a wildcard to retrieve all the file attributes, which is what I'm doing here. This method returns a map, so I'll use the for each method on the entry set to quickly print each attribute key value pair. This method throws a checked IO exception. I will just print a message to the console if there's a problem. Getting back to the main method, I'll comment out the call to the printPathInfo method. I'll then call extraInfo after the log statement call. Running this code, I'll get OS-specific attributes about this file. I've got last access time, last modified time, size, which is a few bytes because of the couple of log statements contained in this file. There's creation time and a few others. If you're using Linux or Mac, you might see a different set of attributes because the results are OS dependent. File attributes are going to be different on different operating systems. In addition to get attributes, there's also get attribute, singular, so you can get one attribute at a time by passing a specific string literal. This slide shows you the possible values for the string literal you can pass to the files.getAttribute method. The files.getAttribute method returns this data as an object, which means you may have to cast it to the actual type shown in the second column before processing. In addition to the getAttributes and getAttribute method, you can get a couple of these fields by specifically named methods on the files class as shown in the last column. Let me show you one more method that will help you understand the content of the file you might be working with. This method is called probe content type, and I'll just print what gets returned for the testing.txt file, running this. You can see the last statement indicating this file has the content type of text plain. You may be familiar with content in the context of web development because the content type is used to indicate the type of data that is being sent or received. Okay, so this video has covered most of the methods available on the path class. I also demonstrated how to use the create directories method and the overloaded version of WriteString on the Files class, which takes multiple options. In this case, I used options that let me both create a file and write to it at the same time. In the next video, I'll be talking about listing out directory contents as well as what's called walking a directory, so I'll see you in that next video.